chapter, the student will be able to state the criteria used to determine whether goods should be considered as dangerous, and identify the main characteristics of the 9 classes and their respective divisions to which dangerous goods are assigned. The classification is described in Part 2, contained in Volume 1 of the Imdg Code. All chemicals are, to greater or lesser extent, hazardous to human health or to the environment. While a chemical liquid may not necessarily damage the skin on contact, it could be dangerous if consumed. The hazard posed arises from either the substance or article itself, often caused by a change in its storage or transport condition, or by reaction of the substance or article with other substances in the surrounding environment. For safe handling, the UN has divided hazardous substances and articles into 9 classes, based on the type of hazard that they present. The purpose of classification is to divide dangerous goods into broad groups according to the hazard, or the most predominant of the hazards, they represent. The potential for harm to personnel, the environment, or equipment has been assessed in terms of reactivity, flammability, toxicity, and corrosiveness. There are 9 classes, some of which have been further sorted into subgroups called divisions. Note that the order of the class numbers does not indicate the degree of danger, but only the type of hazard. The classes are 1. Explosives, 2. Gases, 3. Flammable liquids, 4. Flammable solids, substances liable to spontaneous combustion, substances which, in contact with water, emit flammable gases. 5. Oxidizing substances and organic peroxides. 6. Toxic and infectious substances. 7. Radioactive material. 8. Corrosive substances. And 9. Miscellaneous dangerous substances and articles and environmentally hazardous substances. Chemical explosions are usually caused by very rapid burning of a substance or mixture of substances in the presence of oxygen in the air. Class 1 explosives has 6 subdivisions according to the sensitivity of the explosive and the hazard it presents. The divisions are described in Part 2 of the Code and indicated for each applicable substance in the dangerous goods list. For example, nitroglycerine has a mass explosion hazard and is classified as 1.1, while fuses, safety, present only a small hazard in the event of ignition or ignition during transport and are classified as 1.4. Goods of Class 1 are considered to be compatible if they can be safely stowed or transported together without significantly increasing the probability of an accident or the magnitude of the effects of such an accident. With this in mind, goods listed in this class have been divided into a number of compatibility groups, each assigned a letter. Click on the button to see a table of compatibility groups and classification codes. The transport condition of a gas is described according to its physical state as compressed gas, liquefied gas, refrigerated liquefied gas, dissolved gas, or absorbed gas. Class 2 is further subdivided according to the primary hazard of the gas during transport, that is to say, whether it is flammable, such as butane, non-flammable or non-toxic, such as nitrogen, or toxic, such as chlorine. For the purposes of Class 2 goods, the term toxic has the same meaning as poisonous. Class 3 includes the following substances and is subdivided into two divisions: flammable liquids, such as benzene, with a flash point of -11 degrees Celsius, and liquid desensitized explosives, such as nitrocellulose solution. The substances listed in Class 3 in the dangerous goods list shall generally be regarded as chemically pure. Flashpoint may vary if the substances contain added substances or impurities. Class 4 comprises both inorganic and organic substances other than those classified as explosives, which, under conditions of transport, are readily combustible or may cause or contribute to a fire. Class 4 has three groups: flammable solids, self-reactive substances, and solid desensitized explosives, such as magnesium powder, substances liable to spontaneous combustion, such as white phosphorus, and substances which in contact with water emit flammable gases, such as aluminium powder. Class 5 is comprised of two groups: oxidizing substances, such as hydrogen peroxide, stabilized, and organic peroxides, such as organic peroxide type B, liquid. Oxidizing substances will, under certain circumstances, directly or indirectly produce oxygen. For this reason, oxidizing substances increase the risk and intensity of fire in combustible material with which they come into contact. Mixtures of oxidizing substances with combustible materials are dangerous because such mixtures are readily ignited, in some cases by friction or impact. Most oxidizing substances react violently with liquid acids, creating toxic gases. Organic peroxides are liable to exothermic decomposition at normal or elevated temperatures. The decomposition can be initiated by heat, contact with impurities, friction, or impact. Decomposition may result in the evolution of harmful or flammable gases or vapors. It is particularly important to avoid contact with the eyes at all costs. This is by far the most dangerous group of substances, although the dangerous properties can be controlled by a number of measures, such as the addition of dilutants or temperature control. Substances in this group are prohibited for transport on ships carrying more than 25 passengers and are only allowed to be stowed on deck on cargo ships. Class 6 deals with toxic and infectious substances and is comprised of two groups: toxic substances, such as arsenic, and infectious substances, such as medical waste. For the purposes of Class 6 goods, the term toxic has the same meaning as poisonous. All radioactive materials are dangerous to a greater or a lesser degree because they emit radiation, which is invisible and may damage body tissue. This damage arises either from external irradiation or from internal irradiation following the intake of radioactive material into the body. The carriage of radioactive materials involves special procedures and equipment. Part 2 of the Imdg code contains many specialized details relating to radioactive material, including a table of radioactivity levels by substance. Other specialized material characteristics relating to low specific activity materials, surface contaminated objects, special form radioactive materials, low dispersible materials, and fissile materials are also explained in this section. Uranium hexafluoride. Fissile is an example of material in this class. Corrosive substances, by chemical reaction, will cause severe damage when in contact with living tissue, or, in the case of leakage, will materially damage or even destroy other cargoes or the framework of the ship. Acids and sodium hydroxide are examples of substances in this class. Class 9 covers substances and articles which present a danger not covered by other classes in the code. They include substances and articles which experience has shown to be of such a dangerous nature that the relevant provisions of SOLAS, as amended, shall apply. Substances not subject to the provisions of SOLAS, but to which the relevant provisions of MARPOL apply. Substances that are transported or offered for transport at temperatures equal to or exceeding 100 degrees Celsius in a liquid state and equal to or exceeding 240 degrees Celsius in a solid state, and genetically modified microorganisms and genetically modified organisms which fall outside the definition of an infectious substance. Examples of substances in this class are blue asbestos, stabilized fish meal, and lithium metal batteries. Substances considered hazardous to the aquatic environment are now considered together with Class 9 substances and articles for the purpose of classification under the Code. Marine pollutants are substances which are subject to the provisions of Annex 3 of MARPOL 73/78 as amended. These substances are indicated by the symbol P in the index and in the dangerous goods list. If they fall within the criteria of any of the classes 1 to 8, such marine pollutants shall be transported under the appropriate entry according to their properties. If they do not fall within the criteria of any of these classes, they shall be transported under the entry Environmentally Hazardous Substance, Solid NOS, UN 3077, or Environmentally Hazardous Substance, Liquid NOS, UN 3082, as appropriate, unless there is a specific entry in Class 9. Dangerous waste material shall be transported in accordance with the relevant international conventions, and, where it concerns the transport by sea, with the provisions of the Imdg Code. Waste containing only one constituent, which is a dangerous substance, shall be regarded as being that substance for the purposes of the Code. If the concentration is such that it continues to present a hazard, it shall be classified according to the criteria of the applicable classes. Waste containing 2 or more dangerous constituents shall be classified under the applicable class of the predominant hazard. Wastes harmful to the marine environment only shall be transported under the Class 9 entries as Environmentally Hazardous Substance, Liquid NOS, UN 3082, or Environmentally Hazardous Substance, Solid NOS, UN 3077, as applicable, with the addition of the word waste. To completing this section, the student will be able to identify the information to be found in the Emergency Response Procedures, the Medical First Aid Guide, Reporting Procedures, Packing Cargo Transport Units, the Safe Use of Pesticides in Ships, the Carriage of Nuclear Materials, and Appendix, Resolutions and Circulars. In many cases, an incident involving leakage from packaged dangerous goods on voyage will simply be contained by the ship's crew and left for specialist contractors to handle further. However, even that preliminary approach can be dangerous, and certainly if a fire breaks out, fast and effective action by ship's personnel will be required. The initial response to any emergency will be in accordance with the shipboard emergency plan. The emergency response procedures for ships carrying dangerous goods, known as the EMS Guide and contained in this supplement, are to be considered in support of such action and as providing a reference source on emergency response techniques and should therefore be integrated into the vessel's safety management system. The emergency procedures are developed for a shipboard response where the master and crew have to react to and counter a fire or spillage without external assistance. In order to develop familiarity with its contents, the EMS guide should form an integral part of the emergency training schedule on board. All crew members should be thoroughly familiar with the introduction section of the guide. During the planning stage of a loading operation, those responsible should note the emergency schedules for the dangerous goods to be loaded. In the event of an emergency, the emergency schedules should dictate the nature of the response adopted by the crew. The EMS guide delivers guidance on dealing with fires and spillages of these substances on board ships. It contains the following sections: Introduction, Firefighting; General Guidelines, Fire; Emergency Schedules, Fire; Introduction, Spillage; General Guidelines, Spillage; Emergency Schedules, Spillage. Index. The introduction provides an overview of the planning and execution of firefighting techniques and precautions for emergencies involving dangerous goods. The general guidelines are a single page of bullet points highlighting the significant steps in an emergency response to a fire involving dangerous goods. The emergency schedules for fire are contained in a table and all bear the prefix letter F. They are divided into individual schedules from A to J. Each contains general comments and specific guidelines according to the location on board. Special cases to which the schedule applies are indicated by the UN numbers of the substances concerned. The example here shows Fire Schedule FE, Non-Water Reactive Flammable Liquids. Note the guidelines for different stowage areas and the UN numbers of the special cases to which the schedule applies. The introduction provides an overview of the planning and execution of spillage recovery techniques and precautions for emergencies involving dangerous goods. The general guidelines are a single page of bullet points highlighting the significant steps in an emergency response to a spillage involving dangerous goods. The emergency schedules for spillage are contained in a table and all bear the prefix letter S. They are divided into individual schedules from A to Z. Each contains general comments and specific guidelines according to the location on board. Special cases to which the schedule applies are indicated by the UN numbers of the substances concerned. The example here shows spillage schedules SO, substances dangerous when wet, non-collectible articles. Note the guidelines for different stowage areas and the UN number of the special case to which the schedule applies. The index cross-references dangerous goods, identified by their UN number, with the applicable EMS fire and EMS spillage schedules. Underlined EMS codes indicate special cases where additional advice is given for the particular substance, material or article in the emergency response procedures. The International Medical Guide for Ships, published by the World Health Organization, is a general guide for medical treatment at sea. The Medical First Aid Guide for use in accidents involving dangerous goods, generally referred to as the Imdg, is a supplement to this guide and is jointly published by the International Maritime Organization, the World Health Organization, and the International Labour Organization. The Imdg is written around the substances, materials and articles covered by the Imdg code and the materials covered by the IMSBC code. It is intended to provide advice necessary for the initial management of chemical poisoning and diagnosis within the limits of the facilities available at sea. The guide is divided into sections which are structured to permit a rapid and easy three-step approach to secure the required medical advice. The emergency action diagram is the first of two yes-no style flow diagrams aimed at establishing the casualty's immediate situation. This is followed by the diagnosis diagram, aimed at identifying a casualty's symptoms. A series of 20 separate tables then give brief instructions for individual special circumstances. Table 1 is concerned with rescue techniques. Tables 2 to 20 are concerned with first aid techniques and are divided into sections which list signs and symptoms, the corresponding medical treatment, and, where applicable, the follow-up required. The user will be referred to appendices and other relevant tables covering specialized medical procedures and descriptions of the consequences of exposure to dangerous goods, if applicable. The reporting of incidents involving harmful substances and marine pollutants is regulated under Protocol 1 of MARPOL 73/78. Recognizing that incidents at sea may give rise to the accidental discharge of substances which cause pollution or presents a threat of pollution, MARPOL 73/78 identifies the need for any such incidents to be reported without delay in order to mobilize the necessary coastal state response. The reporting procedures in the supplement outline the general principles for ship reporting systems and ship reporting requirements, including guidelines for reporting incidents involving dangerous goods, harmful substances, and/or marine pollutants. Specific company, terminal, and port reporting requirements should always be followed. This section contains the International Maritime Organization, International Labour Organization, and United Nations Economic Commission for Europe guidelines for the packing of cargo transport units. Improper or careless packing of freight containers, swap bodies, vehicles, and other cargo transport units can lead to personal injury and material damage. These guidelines are intended to provide advice on safe packing of such units and a basis for training on such operations. Existing regulations and recommendations, such as contained in the company operations procedures, shall always be complied with, and this section is only to be read in support of such directives. Where dangerous goods form only part of the contents of a cargo transport unit, the dangerous cargo consignments should, wherever possible, be packed adjacent to the doors, in a secure manner with markings and labels visible. This will permit easy access in the event of a problem. The recommendations in this section are intended as general guidance for use by competent authorities, mariners, fumigators, fumigant and pesticide manufacturers, and other interested parties. The control and eradication of insects and rodents is essential to prevent the spread of infection and disease. The International Code for the Safe Carriage of Packaged Irradiated Nuclear Fuel, Plutonium, and High-Level Radioactive Wastes on Board Ships, or INF Code, is mandatory under SOLAS 1974 and is reproduced in the supplement. By definition, it relates to the carriage of various forms of radioactive material and waste. Vessels carrying such materials are bound by the requirements of both this code and the Imdg code. The appendix to the supplement contains the resolutions and circulars referred to in the Imdg code and its supplement, including those of the IMO Assembly, the Maritime Safety Committee, the Facilitation Committee, and the Subcommittee on Dangerous Goods, Solid Cargoes and Containers. Annex 2 of MARPOL 73/78 also includes requirements for the prevention of pollution from dangerous goods which are transported as packages, in containers, in transportable tanks or in road tankers. Where applicable, these should be read in conjunction with the provisions of the Imdg code. The student will be able to identify the Imgd code requirements with regard to stowage, segregation, cargo transport units on particular vessel types, and temperature control provisions. While the previous chapters have addressed provisions for individual packages and the substances they contain, the potential problems are multiplied when they are all brought together in the same ship. The way that they are loaded is called stowage. The way in which problems that adjacent packages can have on each other in the event of an emergency is avoided is by a process called segregation. Of course, one of the most dangerous ways in which a hazard may spread is through fire, and an understanding of the ways in which this is restricted or prevented is important. Ships are divided into two groups for the purpose of making appropriate stowage recommendations. 1. Cargo ships or passenger ships carrying a limited number of passengers. This number is a maximum of 25, or calculated as 1 per 3 meters of length of the ship. 2. Other passenger ships in which a larger number of passengers is carried. Substances, materials, and articles shall be stowed according to a number of stowage categories. These are as follows. Click the categories for more information. Category A. Cargo or passenger ships as limited above, on deck or under deck. Other passenger ships, on deck or under deck. Category B. Cargo or passenger ships as limited above, on deck or under deck. Other passenger ships, on deck only. Category C. Cargo or passenger ships as limited above, on deck only. Other passenger ships, on deck only. Category D. Cargo or passenger ships as limited above, on deck only. Other passenger ships, prohibited. Category E. Cargo or passenger ships as limited above, on deck or under deck. Other passenger ships, prohibited. If spillages or leakages occur in an under-deck location, precautions shall be taken to prevent the inadvertent pumping of the material through the machinery space bilge system. Drums containing dangerous goods shall always be stowed in an upright position, unless otherwise authorized by a competent authority. This applies to both drums in an open stow and those packed in a cargo transport unit. Fiberboard boxes and other packages susceptible to water damage shall be stowed under deck, or, if they are stowed on deck, be located in a protected location that does not expose them to weather or seawater. At all other times, the stowage of dangerous goods shall be so arranged as to ensure clear walkways and access to hydrants, sounding pipes, and other fittings essential to the safe management of the vessel shall not be impeded, and that any special provisions regarding stowage of dangerous goods possessing a particular hazard can be applied. Packages and other receptacles that would normally be stowed on deck only when in a full condition may be stowed again on deck when empty or under deck, provided the space is mechanically ventilated. Empty, unclean cylinders that have previously contained gas of a toxic nature shall, however, only be stowed on deck. Some substances need to be protected from heat and large temperature variations. Such substances shall therefore be protected from direct sunlight by locating them other than on the top or at the side of an on-deck stow, and be stowed at least 2.4 meters from sources of heat, such as heated tanks, steam pipes, uninsulated machinery bulkheads, and the like. Some dangerous goods are required to be stowed clear of living quarters, because dangerous vapours may leak and be drawn into the accommodation, machinery spaces, or other work areas, through air intakes, ventilation ducts, and openings in bulkheads, such as doors and ports. Clear of living quarters means that packages or cargo transport units shall be stowed in a minimum distance of 3 meters from accommodation, air intakes, machinery spaces, and other enclosed work areas. Marine pollutants are to be securely stowed in such a manner as to minimize the risk of them being lost overboard. Under-deck stowage is preferred where permitted, except where a weather-deck stowage provides equivalent protection. Where on-deck only stowage is required, packages containing such marine pollutants shall be stowed in well-protected areas. Additional stowage requirements also apply, depending on the class of the substance involved. These mainly require packages to be protected from things such as heat, water, sources of ignition, and the build-up of vapours, as well as providing for access and appropriate action in the event of an emergency. When dangerous goods are loaded closely together on a ship, there may be a risk of leakage, contamination, or a dangerous reaction if something goes wrong during the voyage. Careful consideration, therefore, needs to be given to the locations of all packages of dangerous goods. If a dangerous reaction is possible, then those goods need to be separated from each other. This procedure is referred to as segregation. The principles of segregation apply to all cargo spaces, on deck or under deck, and to all types of ship and cargo transport unit. Incompatible goods shall be segregated from one another. Incompatible goods are those which, when stowed together, result in a hazardous situation in the event of spillage, leakage, or any other accident. Secondary hazards must also be considered. The principal manual method of determining which general segregation provisions apply is by reference to a special table contained in the code. Many companies utilize computerized stowage programs, which include electronic versions of this segregation table. Specific information is also given in the dangerous goods list, and the type of ship on which the goods are to be carried also plays a part. Click on the button below to see the table. The following terms are used to define the amount of separation required between packages containing dangerous goods. In increasing order of separation, they are away from, separated from, separated by a complete compartment or hold from, separated longitudinally by an intervening compartment or hold from. The practical implications of these terms depend on the type of ship and the type of cargo transport unit the dangerous goods are packed into, if any. Dangerous goods on general cargo ships may be carried as loose packages in cargo transport units, IBCs, or in loose bulk form. In many cases, more than one form may be on board. There are different definitions for the segregation terms, depending on the way the dangerous goods are packed. Cargo spaces shall be dry and clean to minimize hazards. Flammable dust, such as grain or coal, should be removed. Maximum stack heights of IBCs, etc., must not be exceeded. For the segregation of cargo transport units on full container ships or ships of other types but fitted to provide permanent stowage of containers, there are special tables in the code which clarify the meanings of the segregation terms. Loading and unloading of the vehicle decks on a ro-ro vessel must be properly supervised by qualified and appointed personnel. Such spaces shall be securely closed during the voyage. Dangerous goods packed in cargo transport units are permitted to be stowed in the conventional way on vehicle decks, weather decks, or in cargo holds, provided all requirements of the Imdg code are met and their units are properly secured. Regular inspections of spaces containing such units by an authorized crew member are required in order to gain early detection of any hazard. Because of the unique design features of ro-ro vessels, special segregation provisions again apply to this type of vessel, and again there is a special table in the code. Before loading, cargo transport units used for the transport of dangerous goods shall be examined for damage, leakage, or other evidence of loss of the contents. Any unit found with such defects shall not be accepted for shipment. This is often done well before the unit reaches the ship, but the crew should be alert to damage that may have occurred on the way to the ship. Care shall be taken in the event that a cargo transport unit needs to be opened for any reason. The nature of the contents and the possibility of leakage or the accumulation of toxic vapors leading to an unsafe atmosphere should be considered. Some products react on contact with moisture, and care should be taken wherever possible to restrict the development of condensation within cargo transport units. Similarly, where it is required that dangerous goods be kept as cool as possible, considerations should be given to protecting a cargo transport unit against heat, such as from direct sunlight. Empty cargo transport units, which previously contained dangerous goods, shall be inspected to ensure that no dangerous residues remain. Foodstuffs can be contaminated very easily, and, if then eaten, can lead to very serious health problems. Toxic gases and substances, infectious substances, radioactive materials, and corrosive substances must all be kept separate from foodstuffs. There are specific requirements in the code which state how and where such dangerous goods must be stowed if foodstuffs are also being carried. Certain substances must be carried at specified temperatures. There are different methods of temperature control, and various factors will influence which is employed, including the difference between the control temperature and the anticipated ambient temperatures, the effectiveness of any insulation, and the duration of the voyage. Methods of temperature control include thermal insulation, coolant systems, mechanical refrigeration systems, and combinations of these techniques. Any electrical fittings must be explosion-proof and of an approved pattern.